Yikes. If we weren't able to get it at this point, you don't know what you're doing pretty much, if we're being honest. So let's just go through it together so that we can remember what we learned last time. So there's a few people that did remember. So remember, this is important. You want to always find the least common denominator. So you want to have your denominators factored out. So I'm going to rewrite it. I had a kid yesterday who literally on that entire assignment did not miss any problems in class. He literally got every single one right. And I was like, what is he doing that's so great? Because he's usually not getting them all right. Because he showed every step. Like he wasn't skipping things, so he wasn't getting confused with things that other people were. So let's show our work here. So we have x over, what is that piece right here factor to be? X plus 2, x minus 2. We should all be good with that. Then we have minus 2 over x plus 1. Okay, so now you'd say to yourself, okay, my least common denominator, you can only take care of that by multiplication. So we have an x minus 2 and an x plus 2. And then this one is x plus 1. And there's no way to make that either of those. So you'd say to yourself, okay, yes, the least common denominator is all of them, but it just happened to be. So now we would fix the denominator so that they all have this. So this has x plus 2 and x minus 2. So don't we need an x minus x plus 1? So if you do it to the top, you got to do it to the bottom. Anytime there's two terms, we use parentheses. This one needs both x plus 2 and x minus 2, right? Some people at this point have a really hard time distributing. Now look at your common denominators. Are they the exact same? Okay, yes, right? Now do not start simplifying anything. Of course those are going to divide out. Of course those are going to divide out. We specifically made them 1 on purpose. So you need to distribute this through. So that's x squared. X times 1 is plus x. That's all over this whole denominator. Can I just write common denominator for right now? Everybody understand? Then we have, now multiplying this out, people have issues with. Multiply those two together first, which is this, right? So we're multiplying by x squared minus 4. So careful here. Negative 2 times x squared is negative 2x squared, right? Negative 2 times negative 4 plus 8. That's all over, that was just this half, all over the common denominator. Now, the whole point of that, you would not at this point then refactor and simplify, you're going to end up back here. From here, the whole point of doing that was so we could combine the top together. Does everybody understand that? So now let's add up our numerator, the top of our fraction is called a numerator. Let's add that up. X squared, negative 2x squared. Now we've already taken care of the negative, so we're just combining like terms. Negative x, 1x squared, right? We just added those two together. X, any other x's? No, so plus x plus 8. That's all over the common denominator. Now we need to write it. We have our x plus 1, our x plus 2, and our x minus 2. This came out different than I was expecting. In my head, I saw it coming out differently. But we haven't made any errors, correct? We've been doing it right. So now we would say, does the top factor? Now we're just simplifying. So something went wrong over there. But I didn't catch it because that's how I saw it coming out in my head. Okay, so wouldn't we, I personally would choose to multiply, because there's a negative in front, I'm going to factor out negative 1. So that's x squared minus x minus 8 all over x plus 1, x plus 2, and x minus 2. So then you say, does this factor? What multiplies to be negative 8 and adds up to be negative 1? That's it. So no, it doesn't factor. So we know it doesn't simplify. So this is our answer. Yikes. Is everybody okay with that? Okay. So, addition, you have to have a common denominator. Now we want to factor out our denominators if possible. So we have 2k over, that doesn't factor, so 5k minus 7. Then we have, okay, plus 6k over 3k plus 7. Yep, 8. Okay, so then you would figure out what your least common denominator is. So, least common denominator, I'm going to write right here. Least common denominator. This 5k minus 7 is connected, so we definitely need that. We have a 3. I'm going to put the 3 in front just to write it more appropriately. And then we have a k plus 8. So this one's all of the denominator, correct? So then you'd say to yourself, what does this one need? It has a 5k minus 7. Don't we need a 3 and a k plus 8? So we'll multiply by 3, k plus 8. Use parentheses. 3, k plus 8. And then this one has a 3 and it has a k plus 8. We need a 5k minus 7. Now you'd say, are all of my denominators exactly the same? Look at them. Okay, let's just call it common denominator from here on out. Now you need to multiply out the top. So let's multiply this out correctly, guys. Technically, that's 3 times 2 times k, which is 6k, correct? 6k, k plus 8. The reason I did that is to make sure I don't make any errors when trying to multiply it apart. 6k times k is 6k squared. 6k times positive 8, positive 48k's, correct? That's all over the common denominator. I think a lot of us skip that step and then you get confused. So now let's multiply this out. 6k times 5k is positive 30k squared, right? And then we have positive 6k times negative 7, which is negative 42k's. All over the common denominator. Now look, you have 2 fractions still. The whole goal of doing that was getting a common denominator so we can now combine our like terms on top. So 6k squared plus 30k squared is how many k squareds? 36k squareds, right? Check, check. 48k minus 42k. Plus 6k. Awesome. That's all over what was the common denominator. 3. 5k minus 7 and k plus 8. So we've done the addition part. Now we'd say, can it simplify? So on top, we should be factoring out a 6k. So then left would be 6k plus 1, right? Is everybody following me? I can't tell. And then on bottom, we have our 3, our 5k minus 7, and our k plus 8. So now you can divide out exact factors or multiplication. 6 and 3 become 2 and 1. That's it. So on top, we have 2k, 6k plus 1, and on bottom, we have 5k minus 7 times k plus 8. They are definitely the hardest problems of the unit. I mean, only because, like, really they're not too bad, but it is like a lot of room to make error and get confused places. Okay, questions on that? Does it feel a little bit better? Okay. Do this one, let's do some review because we have learned a lot this unit, so let's see where we're at. So take your whiteboards out, let's do some review before we learn the new stuff. So I want you to do this problem. This is the first lesson we learned in this unit. Simply simplify this and state the excluded value. Let's go through it because I was seeing it in my head here. So we would say we're going to factor the top. It is not quadratic because that's what simplifying is factoring. So we factor out a p. Left is 2p squared minus 1p minus 3. Then you would not stop there. You'd say, I recognize that that's a quadratic. Well, multiplies to be negative 6, a times c, and adds up to be negative 1. 2 times 3, negative 3, correct? So we drop 2p squared, we drop down negative 3, and we're breaking down our middle term, rewriting it as those two factors but with p. So plus 2p minus 3p. So then we'll factor by grouping. So in common here is a 2p. So left is p plus 1. Is everybody good? If not, you got to say no. Because when I hear yeah and then a few head shakes yeah, I'm like, okay. But then I forget that there's other students too, you know. We're all good? Okay, in common here is what? Negative 3, and then left is, so we know it does factor because our safe haven's the same, so factor out p plus 1, and left is 2p minus 3. Okay, so, yeah, 2p minus 3. So we had, let's keep our work straight. I'm going to write it over here. So on top we factored out a p to begin with, then we had a p plus 1, and then we had a 2p minus 3. Now let's factor the bottom out. So I'm going to come back up. What's in common here? 3p squared. Very good. So divide by 3p squared, divide by 3p squared. And left is 2p minus 3. Okay, so then from there we would say, we factored it all. Now we've got to restrict our domain. So p cannot equal 0 for that piece and 3 has for this piece. Okay, now we can divide out exact factors. P on top, p on bottom. So that becomes a p on bottom, right? P minus 3 and p minus 3. So our answer is p plus 1 over 3p. And a lot of you got that right. Awesome. Good. Yay. Okay, let's do another review problem. Here we go. Really does? Oh, okay, I'll be more careful. So do this one. Would someone do this? And I don't want you talking. I want you listening. Yeah. Hey, listen. Maybe he's wrong and we'll help him fix it. Maybe he's right and we'll learn. Okay. Or we'll check it.
So the first rule that I know about this is that you always have to put the bottoms to go to multiplication. And the first thing I'm going to do is I'm going to factor the 2x squared off the top one on this. So that'll be x plus 1. Then on the bottom here, I'm going to factor out x. So it'll be x minus 3.
How many of you were able to get that far at least? Raise your hand. Okay, awesome. Continue.
Okay, and then on here, I factored out 3x squared. Then that will be x minus 3. And then on the bottom, that's a quadratic, so you want to figure out what multiplies to equal negative 6. Allows this to be negative 1, that's negative 3, and positive 2. That's over x minus 3 and x plus 2.
Okay, step off to the side. How many of you got that far? Okay, awesome.
Okay. And now what I did is I just started on the left side and seeing what I can cancel out, and all I have to cancel out was this. I can just take off that x, and now take off that x squared. So that'll be a 2x on x plus 1 over x minus 3. And on this one, this x minus 3 and this x minus 3 are in common, so I can take those out. That'll be times 3x squared over x plus 2. And so what I did was I multiplied these two together. So that was 6x cubed for me times x plus 1. Then I multiplied these, so that would just be x minus 3 times x plus 2.
Perfect. That was a beautiful explanation, like perfect explanation. Okay, perfect. Perfect, yes. Okay, awesome. Thank you so much. Okay, that explanation, and notice his work was beautifully laid out. It made it less confusing and no errors. Perfect. Okay, awesome. Next problem. Thank you so much. Okay, do this one. Simplify and state the excluded value. Awesome. That's great. Okay, so you would say I can't subtract anything without a common denominator. So isn't this common denominator? Now think about it, guys. Think about this. This will help some of you. Since this is a 1, Okay, so think about it advancedly, guys. Since this is a 1, we don't need to factor this out right now, because don't we know that the least common denominator is going to be all that stuff, even if it factors? Because this is a 1. So you're not wrong to factor it. So let's do factor it, just because I think that's what most of you did. So let's do it the way you did it. So what is the bottom factor to be? 3x plus 4, 2x minus 1. Very good. And then we have minus 2 over 1. So then we knew we had to multiply by that, which is 3x plus 4 times 2x minus 1 to the top and bottom. Okay, now let me explain what I was talking about again. This is where people have a hard time multiplying out this correctly. So what I want you to do is look at it like this. X over the common denominator minus 2 times, isn't all that? So let's do negative 2 times that, because that's already multiplied out for us. 6x squared plus 5x minus 4. Does everybody understand? And that's all over the common denominator. So you've got to distribute that negative 2 through. Remember, with addition, we're trying to combine the top, but you can't do that until you distribute. So that's negative 12x squared. Got to distribute the negative. Minus 10x, very good, and plus 8. That's just that piece, all over the common denominator, and we still have x over the common denominator. So now are we just going to combine like terms on top? Good. So, negative 12x squared, no other x squared, x minus 10x, minus 9x, plus 8. Because we already distributed the negative, and that's all over, you said it was 3x. Okay, then you would just look at this and say, so those of you that had the signs, do you see where the signs got off? Yeah. This group, you're okay? So you were able to figure out where you went wrong? Yeah. Okay, good. You were super close, just off by sign. Okay, awesome. And then we would check to see if the top factors, and it doesn't. So we're done. Okay, awesome. Continuing with rationals. Once again, this is one of the hardest units, probably of the year. Today is not too bad, but it's definitely not easy. So pay attention. So today we're going to actually be solving rational equations. So now we're going to actually solve rational equations. So the first day we simplified rationals, second day multiply and divide, third day add and subtract. Now we're solving them. So here's the thing, guys. This is actually pretty nice. You're going to find this much easier than last time. When solving a rational equation, the hardest part is you do have to have a common denominator, just like when adding and subtracting. But once you have a common denominator, you can literally just ignore the denominator and solve using the top. So then it's easy from there. Once you get a common denominator, you can solve using the top. So if I gave you this problem and said solve, do you see how you have a common denominator? You can literally ignore it and just use the top to solve. So we have x minus 2 plus x minus 4 equals 2. Solve for x. Combine like terms, right? 2x minus 6 equals 2, correct? So we would add 6. So we have 2x equals 8. And then divide by 2 and we get x equals 4. Pretty easy, right, everybody? Does everybody understand? Okay, awesome. So now we would check our answers. We've got to check our answers because we took and we manipulate, well, not on this one we wouldn't need to check because we already had a common denominator. But if you change the problem in any way, you need to go back and plug that answer in and check your answer to see if it's truly a solution. Because there's something called extraneous solutions. Now an extraneous solution is a solution you get, you've done all the algebra correctly, you solve and you get something, but if you plug it back into the original equation, it's not a true statement. So let's say we plugged in 4 and got 0 equals 2/3. Isn't that not true? If we did plug in 4, that's not what it is. I'm giving you an example. Then that's not true. So we would throw that answer out. It's an extraneous solution. Because we're taking and changing these problems so much that it can introduce extraneous solutions. So you just got to check your answers. Does that make sense, everybody? So let's say we threw that answer out, then we'd say no solution. Does that make sense, everybody? That is the answer. We plug in 4, it's going to work. 4 minus 2 over 3 plus 4 minus 4 over 3 equals 2 over 3. So isn't that, 4 minus 2 is 2/3, right? plus 0, or plus 0 equals 2/3. Isn't 2/3 equal to 2/3? So it was truly a solution. I was just giving you a different example. Okay. All right, let's just start practicing. All of my stuff's coming out of your worksheet to help get less homework. Let's fly through this. So we say to ourselves, I can solve any rational equation. Now, why is it solving? Because there's an equal sign. We haven't had any equal signs, right? So we'd say we can solve this as long as we have a common denominator. So let's get the least common denominator here. 3, 2, 1, correct? 6. So let's fix this to be a 6. Don't we need to multiply by 2 over 2? Now we need to make this denominator 6. So we need to multiply by 3 over 3. And this denominator needs to be 6. So 6 over 6. Is everybody good? So let's rewrite it. We have 2x over 6 plus 3x over 6 is equal to 60 over 6. Does everybody see how I'm just multiplying those out? Now don't we have a common denominator? Look at it. So now we can ignore it and solve using the top. 2x plus 3x equals 60. Solve for x. 5x equals 60. So x equals 60 divided by 5. Okay, good. Wasn't that pretty simple?
Is this going to be easy or is it going to be hard?
If you know how to do that, you can pretty much do all of them. Same idea. Let's do this one, number 2. You would say, okay, I'm solving an equation, a rational equation. I need a common denominator. This is technically 0 over 1, correct? So let's go off to the side and say, what's our least common denominator? X times 9, 9x, right? So we're going to multiply by 9 over 9, x over x, right? Doesn't this need 9x? And 9x. Okay, let's rewrite it. So we have multiply straight across 9 over 9x minus x squared over 9x is equal to 0 times anything is 0 over 9x. Now don't we have a common denominator? So now we'll solve using the top. 9 minus x squared equals 0. Solve for x. What would you do first? I like that idea. Subtract 9 from both sides. Negative x squared equals negative 9. Then what would you do? I like that. Divide both sides by negative 1. X squared is equal to 9. Square root both sides of the equation. Root cancels out with power. X is equal to? Plus and minus 3. I thought someone would remember that. Plus or minus 3. When solving and taking a square root, we have to account for the plus and minus. So we get positive 3 and negative 3, so we'll plug it back in to check it. We've got to check our answers. So well, I'm not going to have time to do that right now, so I'm just going to tell you that one works. Okay? Because we just don't have time to check our answers right now. Everybody good with that? No? Okay, let's do number 3. A little bit harder. Here we go. So we would say we need a least common denominator, right? X plus 1 is in the denominator and also 3x plus 1, right? Everybody? So we're going to multiply this one by 3x plus 1 over 3x plus 1, and we're going to multiply by x plus 1 over x plus 1. So parentheses, parentheses. Now our denominators are the same, correct? So let's ignore those and solve using the top. So that's negative 12x minus 4 equals 5x plus 5. And now solving's easy. Let's combine our x's. So I'm going to add 12x. So I have negative 4 is equal to 12x plus 5x, which is 17x's plus 5, right? Solving for x, so minus 5. Negative 9 is equal to 17x. Divide by 17. And that doesn't simplify. So we're going to have fractions. We're not going to always have gorgeous answers. So it's a secondary 3 now. Okay, that's great. Everybody good? Okay, do this one. Do number 4 on your homework. Everybody doing number 4. What do? Get a common denominator. Then you can just solve these in the top. Good. Do I need to go through it, or are we okay? Because if we don't need to go through it, let's not waste time. If you all got it, let's move on. If you got it, raise your hand. Okay, then we're going to move on because that's majority rule. Okay, do number 5. Perfect. So you multiplied by, if you've already got this, keep moving on, ignore me. But I know there's people out there that need to see it. So if you've got it, keep moving on. So we multiply by 3 over 3, this 4 over 4. We've got to put parentheses around that because there's 2 terms. Now the bottoms are both the same, so we can ignore that. So we have 9x is equal to, we've got to distribute that. So that's 20x plus 4. Then it's just solving for x. Subtract 20x from both sides. Negative 11x equals 4. Solving for x, divide by negative 11. So that would be our answer. Okay. Yep. Go for 6. Right?
I don't know.
We can move on past it. So what would we do, guys? Add 6x to both sides. Eight x plus 3, subtract 3, right? Minus 3. So then we would add 3. So we have 18 is equal to 8x. 8. So that becomes, which simplifies because they both divide by 2. Okay, practice these ones.
No, we did. You added
7 through 9 and then 13 through 21 on the front. Keeping the fair teacher that I am. Because I am fair and I think about your well-being. So let's make a good deal, okay? I do feel like where it was such a short lesson, we're going to cross out 13 through 21 on the front only. Now, here's the thing. If you're struggling, you really need to go back and practice those problems. Does everybody understand? We're not done learning, so don't get me wrong. We still have some more things to keep going, but that's why I'm crossing those out. So right now you're working on 7 through 9. Okay, let's do number 11 together. Here we go. It's on your worksheet, so yeah. Okay, number 11, here we go. So now notice something. We want to make sure we're doing, watch, this one's different. You definitely want the least common denominator, otherwise you're going to end up having to solve something that you cannot solve. So you're not going to just multiply by anything. Let's rewrite this, all the denominators in factor form. So this doesn't change. We have 2 over x plus 3. We have plus 5 over, shouldn't we rewrite this in standard form, negative x plus 3? That's what we know about math, right? We write things in standard form. And then we have 6 over, let's factor that. Well, it multiplies to be negative 9 and adds up to be 0. 3 times negative 3, right? So this piece is x plus 3, x minus 3. Now be very careful because we're still not done simplifying. We actually technically have not factored this piece, because isn't it when we have a negative in front that we need to factor out a negative? So I'm going to hurry and rewrite this because I don't want to get confused. So we have this, and then we have plus 5 over, we factor out negative 1, and left is x minus 3, and that's equal to 6 over x plus 3, x minus 3. Okay, now careful here. Think about it. Let's think advancedly and make our lives easier. Isn't 5 divided by negative 1 negative 5? So shouldn't we pull that negative up so that we don't have to deal with it on our bottoms?
Sure.
Yeah, that's going to make our life easier. So I'm going to say 5 divided by negative 1 is really negative 5. So now we're dealing with just posit that without a negative. So our least common denominator is x plus 3 and x minus 3, correct?
Yeah.
Okay, so let's fix all our denominators that we need. This has an x plus 3. What does it need? Good. X minus 3 over x minus 3. Put it in parentheses. This one needs x plus 3, right? Over x plus 3. Now, did we need to fix that one? No. Look at your denominators. Are they the same? Yep. So now we can just cross them out and focus on solving the top. So, is everybody mentally caught up to here? Okay. 2 times x is 2x. 2 times negative 3 is negative 6. Careful, right? Here's where people make errors. Negative 5 times x is negative 5x. Negative 5 times positive 3. Negative 15, and that's equal to 6. Now we're just simply solving for x. Negative 3x minus 21 equals 6. Solving for x. Negative 3x equals, when we add 21, divide by x is equal to negative 9. Is everybody feeling good about this? Okay. Do number 10, very similar to what we just did. We need to factor everything out before we start figuring out the least common denominator. Your back page, here we go. Helping you out on some homework here. So let's focus on number 1 on your back page. Let's go through it. We say, okay, we're solving an equation that's rational, so we need a common denominator. So what's the least common denominator? 3n definitely has to be there, right?
Yeah.
3n taken care of. N squared. Isn't that only 1n? So don't we need another n? 3n squared. How do we make this piece 3n squared? Multiply by n over n. And what about this piece? N over n to make it n squared. And then what about this one? 3 over 3. Okay, 2 terms means you need parentheses. So let's now look at our denominators. Aren't they all 3n squared? So now we can just focus on the top. N times 1 is n. Plus 5n, right? Equals 3n plus 18. Then from there, we'll continue to solve. Subtract. Well, let's combine these. So that's 6n equals 3n plus 18. Now you subtract 3n. So we have 3n is equal to 18. N equals 6. It's not negative, right? Everybody good with that one? Okay, do 1 through 5.
It's really long. Can you?
Okay, let's go to problem 11 on the worksheet. This one's very different for a reason. So here we go. Number 11, it's different. So you would say, okay, I need my least common denominator. This is an n, so we definitely need an n. 2n squared. So don't we just need 2n squared? Can we make n 2n squared? Can we make 2n squared? So it's 2n squared. So we need this to be 2n squared. So won't we multiply by 2n over 2n? Over here, that one's good, right? You guys need to focus because you're going to be like completely lost. So we're going to multiply by n over n. Okay, so now if there's two terms, we need parentheses. So let's now look at our denominators. I'm going to rewrite this one. We have 2n over 2n squared plus 1 over 2n squared equals n times n plus 2 over 2n squared. Now our denominators are the exact same, so let's just focus on the top. So don't we just have 2n plus 1 equals n squared plus 2n. So now you'd say to yourself, I have a quadratic, correct? How do we solve quadratics? We get them, yeah, factoring's the right idea, but what do we first need to do? Make sure it's set equal to 0. Okay, good. So let's get this quadratic set equal to 0. So we're subtracting 2n, subtracting 2n, we're subtracting 1, subtracting 1. So don't we add straight down and get 0? Is equal to, combine like terms over here, n squared. Don't those happen to cancel out? N squared minus 1. So then you say to yourself, how do we solve this quadratic? I'm going to solve this one by factoring. What multiplies to be negative 1 and adds up to be 1. 1 times 1, negative 1 times 1, right? Nope, adds up to be 0, I meant to say, right? Why would I do it that way? Here's why. Just for this one, I'm doing it this way because let's pretend there was a middle term. Then would you know how to solve? Does that make sense? Yeah. So you're just solving by taking square roots, which is totally fine. I just chose to do factoring method on this one. So we have 0 is equal to n minus 1 times n plus 1. So now we can set each of those equal to 0. So don't we get n is equal to positive 1 and n is equal to negative 1. So you were saying we could have added 1 square rooted plus and minus. We would have ended up at the same answer, right? Okay. Questions? No. Because solving quadratics, we could use the most appropriate method. So, finish the worksheet except for we crossed out problems 13 through 21. And we crossed out numbers, so basically 12 through 21 on the front. Go to the front, cross these out. Now, once again, if you feel like you need more practice, do 13 through 21. Advanced thinkers, advanced learners, push yourselves. ACT prep will 22 through 27 will be really good ACT problems. We've already learned how to do that. Remember back to our first unit when we solved literal equations? We solved for any variable just using algebra. Remember back to that. So if you're an advanced learner, you should be doing 22 through 27. If you don't feel like you're an advanced learner, don't do that. But you're in charge of your own learning. If you want to do well on the ACT, I would try those.